Okay, well, thank you all for being here. Before we get started, I think there's a couple logistical things to go over. Maddie.
Okay, good morning, everyone. As you can see, we have a lot of new tech items throughout the room. So you can see that we have microphones on the desks. Obviously, there's not enough for every single person, just based off the receivers that can work in here. So when you would like to talk, you can just turn it on and then pass it. They're really light, they should be pretty easy. So just try and find it next to somebody, because we're trying to work on the audio in here so everybody can hear a little bit better. We're also trying to record the meeting today using this camera, so you guys can all wave because you're on there. And so whenever you are trying to speak, if you can remember to just say like maybe your first name, so we know who's talking. If not, Jeff's going to try as well, just so we have a kind of clear idea. The goal is basically to have this on the website so people can access the meetings afterwards, as well as the presentations.
Just remember to mute when you finish talking, so we don't get any,
Oh yeah. It's pretty silent, like if you're pretty close to the mic, so if you don't, it's not the worst thing, but that's all I have. Thank you.
Well, I can attest to sitting in front of a group, having a mic and whispering over to a chair, and then hearing it, recorded later. Oops. Okay, well, thanks for being here. So today's meeting is our fourth meeting, and the plan today is to really continue where we left off, and there were a variety of presentations that you requested. We're going to give one on the status quo conditions and data describing the Apalachicola Bay system that Sandra will give, and then conditions for a healthy oyster fishery ecosystem. And then we have three other presentations. Portia is going to give us one on the aquaculture industry regulatory framework, and Joe Brooker is going to give us a briefing on the ABS restoration efforts since around the 80s as requested. And Chad Hansen will provide an overview of the Oyster Future stakeholder process, since it's been requested at all three meetings, and so we'll have that presentation. So that's our presentation today. After the presentations, we'll continue going into our four goal areas, A, B, C, and D. We'll talk about any revisions, hopefully not many or any to the vision, goals, and outcomes. I think Anita has one proposal for one of the areas that we'll review. Otherwise, I think we've all agreed these are good. And then we'll talk about what are some other key issues, and then we'll start talking about what are some potential strategies that we'd like to discuss and evaluate that may help us achieve the goal for ecosystem services or for harvest and management and our other areas. And then we'll talk about what performance measures should we use to evaluate whether those strategies actually work. Are these things that we can measure? How will we do so? That sort of thing. And we'll just start with A, B, C, and work through as much time as we have today. We'll continue at our next meeting following through with that. But we're going to start focusing more on strategies and ideas and issues that we want to work on and see whether these would be good, successful ways of enhancing the status quo conditions of our Apalachicola Bay system. Anybody have any questions on the agenda? Okay. You received electronically a facilitator summary report of the January 8th, our last meeting, January 8th. Does anybody have any revisions or corrections to that? If not, by a show of thumbs for accepting the report. Okay. Very good. All right, well then we'll jump right into our briefing. So the first is Sandra will give us the status quo conditions, and then what would be healthy conditions for oyster.
Can you all hear me without the microphone, or do you want me to use the mic? What?
Very good.
Okay. Thank you, Maddie. Right. That's the first one. There we go. All right. So this is rather an extensive topic, so I'm going to give you sorts of bits and pieces of it, recognizing that this is not an extensive overview of the current status of everything going on in the Apalachicola Bay area. Do I control you? Thank you. Thanks, Jenny. Yeah, it is. Yeah. So we're talking about baseline data. I'm sure you've heard the term shifting baselines, where we sort of think of what used to be as our generational memory rather than going back to the way the ecosystem used to be. back in time. So the way we're going to use sort of baseline data in this term, in this context rather, is that it's going to serve as the foundation of our project. So this is where we are now. So from this point, we will measure success as defined by the metrics we come up with from this particular status, from this baseline. So we're not talking about the way it used to be back in the 1800s. We're talking about where are we now. So there's a number of elements of this baseline condition. There's habitat, where's the habitat, what's it look like, environmental conditions, oyster distribution, harvest data, where are we with harvesting, what about reshelling and restoration, and then other fishery species. Again, this isn't all about oysters. Non-fishery species, the hydrology, what's the watershed doing, what's the salinity doing, and then ecological function and ecosystem services. Those are these more sort of umbrella terms. Where are we with those things? So start off with the mapping, the intertidal maps. Grizzle wrote a very nice paper back in 2018. He mapped intertidal areas with using satellites and ground truth, and so he created a really nice foundation for condition of the intertidal areas. And then we use drones to try and drill down into specific reefs and where oysters are on specific reefs, which part of the reef is the sweet spot for oyster development, and then what their condition is. So the subtidal habitats, where we are with that is that we're a little bit behind the curve. So the most recent sort of sonar or bathymetry data comes from this paper, Twitchell 2007. And so things have changed since this time. According to reports from FWRI, these reefs aren't as significant or as well structured as they used to be when this paper was written. So things have changed in the bay, in the subtidal reefs, and so this is something that we really need to address and find out how high these reefs are, where they are they down to the base, are they still existing? That's one thing we need to address. So environmental conditions, we pulled out the ANER data, and so this is impossible to read, actually. So this goes from 1995 to 2019, I believe, for East Bay. And you can see this, if you look at the top right from you can see the salinity, and that flat line is the average. There's a huge variation in salinity, as we all know that. It's a very dynamic estuary, but that average line hasn't changed. So, when we talk about the bay becoming more saline, it happens during drought conditions, but on average, we're still at the same kind of average condition. And we have a lot of fluctuation around that. So this is where the data helps us sort of interpret our perceptions, and that at least in this region, there's periodic shifts, but there isn't a trend, okay? With the temperature, you kind of have to squint at it, but there's a slight increase in temperature over time, but it's very, very slight, but it's there. So these are from some of the other points. Now East Bay is slightly fresher than the other areas. Again, it's kind of hard to interpret, it's very, very noisy. But if you look at the 2007 year and the 2012, those were drought years, and you can see that those salinities don't drop down as far as they did in other years. So we're still getting that noise, lots of fluctuation, but the fluctuation is smaller in those drought years, so that high salinity stays high. It doesn't get moderated by that downfall that's created by the rains. Same kind of thing with, so that's Dry Bar is the one on the left, Cap Point is the upper right, and then the lower right is Pirates Cove. Pirates Cove is generally saltier than the other areas, which one would expect, because it's towards the south of the Bay, a lot of salinity coming in. So anyway, this only goes back as far as 2004, but you can kind of, this is where we are now. These are the fluctuations we see, and this is what our environmental, or our salinity is doing. There are other data associated with these instruments, but I didn't want to put thousands of graphs up. But salinity is an important one, as we all know, so that's why it's being represented. So we do have environmental data from the past, and we have it currently. So we're in good shape there, I think. And we're putting more instruments out. Now, once we get out of Apalachicola Bay, John Brooker has some instruments out in Alligator Harbor and up at the Marine Lab. And the message here is that this is only 2019, these went out recently, but the message here is that at least in this 1 year, you don't get that noise that dominates Apalachicola Bay. So these salinities are more or less permanently above 25 parts per thousand. So this is a very salty environment. It's not like Apalachicola Bay. So how does that influence, oyster populations? And this is important actually because there's a lot of aquaculture going on in Alligator Harbor, and they've had some problems. So we now have this data to try and tease apart what might be causing those. So again, intertidal habitat maps. We're good on that. So what are the oysters doing? So this is again from that paper, Grizzle et al. 2018, and essentially what this shows is that you've got nice spat fall. You've got fairly high densities in the center and the east. Okay? In the west, your density is low, but you're looking at 34 per meter, 429, and then quite high in the eastern part of the bay, nearly 1,000 oysters per square meter. That's pretty good. And we see what we would expect with the shell heights. There's more juveniles than there are adults, but you do see the larger ones. So that's what Grizzle came up with for the intertidal habitats. We haven't done our analysis yet, so this is the current status of the data for the intertidal habitats. And I pulled out two statements from the paper. One was that FWC surveys of the subtidal reefs in 2016 found that only 66 of the 161 sampling stations on mapped reef had oysters. And that data showed that live oyster densities in the subtidal reefs were around 17 per square meter, which is substantially lower. It's about half of the lowest of the intertidal, which I think is telling. Usually one would expect the subtidal reefs to be a lot healthier and more prevalent, more dense than the intertidal reefs, but that is not the case anymore. So or at least a couple of years ago. So these are getting into the FWC data. This was provided by Melanie, who runs the oyster program down at FWRI. So the little V's here you see are the FWRI monitoring stations. And so they divided the bay, as most people do, into east, central, and west. Go ahead. And so the winter bar, the western side of the bay, which is the winter bar, these are the dates, and these teeny tiny little blips are the number of live oysters per meter squared. So you see very, very low. It's like 5, 10-ish. Okay, central. Central's doing a little bit better, but still not stellar. And then east, again, a little bit better. They were up to, well, there's a lot of variation, but they were up to about 150 per square meter. So these are the kind of numbers they're seeing at the moment. This is recent data. So as far as spat fall, again, this is the winter bar, and you see that's not very many spat. When we were out with FWC guys here, they were saying they used to get upwards of 100, 200 spat per shell. So these numbers are nowhere near that. Okay. And this was back in 2015. You can see it has not recovered since then. The central bay is doing, again, a little bit better. And somehow it's still less than 50. And then again, same with the eastern bay, more consistent, less downslide, but still there, but still less than 50 spat per shell. So recruitment's down is the message here. So again, this is kind of our latest data. This is where we are at the moment. Oyster harvest, I'm sure you guys have seen all of this, but catchment unit effort went down around 2012-13, hasn't recovered. And then these are the numbers for the different regions. You see Franklin County, as we know, used to be really, really good, and then boom, crashed down. So I'm sure everybody's familiar with this sad story, but so this is the status, this is where we are with the harvest, with the commercial harvest. Reshelling, there's been a lot of work done since the fishery crashed. Some was done before that through FDACs, and then the reshelling program stopped for a number of reasons. And so this is just a map showing where the restoration efforts have been. And it's kind of hard to see, but all of those little green dots were NERDA-funded projects, restoration projects, and then the yellow ones are funding from Restore. I don't believe this includes the NIFWEF money that FWC has had. Those, I don't know if they're buried in there somewhere, but it's certainly not on the legend. But as you can see, there have been a number of reshelling projects since that crash in 2013. So moving on to the fishes rather than the oysters, this data was pulled out of the FWC FIM data. It's a massive database, so again, these are just a selected number of randomized, sort of dominant species that EdCamp kindly helped pull out of this data set. It's a very complicated data set. So what this shows is not absolute numbers, but it's the average and standard deviation or confidence intervals around the mean of the relative population level. So it basically shows fluctuation around sort of a standardized, this is what patient population looks like. So it shows trends rather than absolute numbers. And the top one, this is silver perch, the top one is Apalachicola, and then Cedar Key, Tampa Bay, Charlotte Harbor, moving south. As you can see here, there's variation, but there's no real trend. It's not like it's going like this or like that. It's just kind of wobbling about. And there is a number of different reasons for that, but it doesn't seem to be following any particular path. And this is shrimp. Again, there's fluctuations around that kind of central line there, but they don't seem to be following any particular path. Again, same kind of message, and these are commercial species. Okay, these are mullet. Mullet don't seem to be doing very well in Apalachicola Bay. They did well back in the late 90s, and then they kind of declined rather precipitously and have kind of wobbled around that low level ever since, and they're sort of in decline now. So again, reasons for that, unclear, but it doesn't seem to be the case in the other regions. So that bears looking into. But whether it's environmental or harvesting or some other reason, we're seeing these trends. So this, well, go ahead.
The time frame when this started?
98.
1990s, I can't, I'm sorry.
Sorry, no, it's okay. It looks small. It looks nice and big on my screen, but I know it's small. So it's 98 to 2016. Yeah. And I think they're all the same time frame, right? You're holding out the same time frame.
Right,
It's
a couple of
96.
different sites started a year or two earlier than that.
Okay,
And we can update these data for the last couple of years.
yeah. There's a lot more information that can be dug out of this data set. It's a huge data set, different gear types, different seasons, different years. It's a really good resource, pulling out information on not only non-oyster commercial fishery species, but also non-fishery species. So pinfish, little bait fish, again, spikes here and there, no clear trend. And then gobies, which are not harvested for anything by anybody for any reason. And again, wobbling about, ups and downs, but no clear trend there. So it seems that at least a cursory look at this fisheries independent data for non-oyster species, that other species in the bay are not showing these precipitous downward trends that oysters are. So do we have an unhealthy ecosystem, or do we think we have an unhealthy ecosystem because we're using oysters as a metric? So this is something that we need to understand in going forward in restoring the bay, as opposed to restoring oyster populations. It's a different kind of approach. So going back to what our baselines are, so we have intertidal habitat maps, but we need to do some catch up on the subtitles. That's important, and it's a priority for our project and for FWC. Environmental conditions, we kind of have a reasonable understanding of those, at least in terms of the physical properties of the bay. Things like nutrients and carbon and all these things that represent food for the animals in the bay. We don't have a good handle on that yet. Distribution, we're getting there. There's There's people working out there. We've got recent data. It's not looking good. So that's definitely something, as we all know, we need to address. Harvest data, serious problem, we know that. Shelling and restoration is ongoing, and we're currently getting data back from those projects, and that will inform us going forward. We can pull out information on fishery and non-fishery species to get a handle on what else is going on in the bay, and hydrology. Steve Lightman's been working on hydrology for probably more years than he cares to count, and so we have good information on hydrology. I didn't put it up there because it's kind of time-consuming and complicated, and I don't think I do a good job in trying to explain it, but we have the hydrology data. It's also strongly influenced by management and climate, so it's a little complicated. Ecological function and ecosystem services, as far as I could tell, digging into the recent literature, we don't have a good handle on that yet, so that's something that we need to address in order to understand whether the bay is healthy or unhealthy. So I'm going to switch gears a little bit here, and I was asked to talk about what oysters need, what makes an oyster population or community thrive. So why are they declining in the Gulf? It could be a number of things. All of these things have caused declines in other areas, and they could be contributing here. Overharvesting, habitat loss, changing environments, specifically high salinities and reduction in freshwater flow, predation, diseases, and then 800-pound gorilla in the room, climate. What's going on with climate? Is it a problem or isn't it? How it influences us? So there's a lot of information on this slide, but what it basically shows is how different parts of the bay vary with all these different factors, and how does that influence oysters. So rather than going cross-eyed trying to read through all of this stuff, I pulled out the piece, or the section of it, that is good for oysters. So, and this again, this is just data that supports what we intuitively sort of understand from being out there. The best salinity is around 15, 10 to 20, not too salty, not too fresh. The middle of the estuary has those conditions generally, and those conditions create decent spat supplement, growth rate, it's good habitat suitability, there's a low probability of flood. Flood creates fresh water, oysters don't like fresh water. The predator abundance is suppressed because of that lower salinity. Fewer fouling organisms, low mortality, and good production potential. So all of these factors that were looked at are sort of highest in the center of the estuary where you have that mid-range salinity. So what influences that? Well, we all know we had droughts back in a 2007 time period, and then 11 and 12, and that was exacerbated, that drought was exacerbated by Atlantis drawing water from the watershed. When there's no water around, everybody needs it, everybody wants it, and tough decisions have to be made about who gets it. And unfortunately, it's usually ecosystems that lose that fight. So there are agricultural withdrawals, there's urban withdrawals, and there's a severe drought. So these management decisions become really important when we have climatic crisis. We have plenty of rain, not so much. So that's what happened, and then so what happens when the salinity goes up? Well, in a low to moderate salinity environment, like the ones in the middle of the estuary, the good zone, you still have predators, there's always predators. Cownose rays take little ones, but they're not a huge impact on the oysters, despite some scuttlebutt about how bad cownose are for shellfish. Blue crab and sheep's head. So these are the sort of moderate salinity animals. And then high salinity predators, these are the ones that are a real problem. Oyster drills are the most important oyster predator in the Gulf of Mexico. It can take out 50% of the population, and these things are voracious. And they are extremely fecund, they lay lots of eggs, and they basically half wipe out the population. Now the problem is, if you've got 5 billion oysters and half of them are wiped out, well, you've still got quite a lot of oysters left. You've got 10 oysters and half of them are wiped out, then you've got a problem. So this predator dynamic shifts with prey density. So that's something that as the number of oysters goes down, up to a point where it becomes self-limiting, this predation problem increases, if that makes sense. They prefer fat in small animals, so again, the juveniles are more vulnerable than the adults. They can get into the adults. These oyster leeches, which are not leeches at all, they're flatworms, they slide in between the mantle and the shell, and they basically start eating the tissue. So the oyster tries to kind of cover them up with shell, which is energetically expensive, one thing, and they don't always succeed. But these worms are really tough. They can tolerate very, very high temperatures and very low temperatures. And those are the conditions under which the oysters get stressed. So not only are they undergoing this stress, they're being eaten alive by these nasty little worms. And so this kind of any sort of multiple stress situation can sort of tip these animals over the edge into mortality. But these guys can't tolerate low salinity, so if we get a nice low salinity, a freshwater influx, we can knock them out. These are high salinity predators. It's hard to tell what the mobile predators are doing. It's a little bit harder to make those correlations. But stone crab will basically crack anything that they can get their claws around. And then the black drum, they prefer the small to medium. So the message here is that the small to medium oysters are the ones that are vulnerable to many things, particularly predation and diseases, or parasites rather. Once they get to that big size, they reach a sort of size refuge from a number of things. Okay. Boring sponges, these can be a real problem in some places that have very high salinities persistently, because they bore into the shell and it's hard to shut them. The shells break apart. And this is a serious problem in North Carolina where they have high salinity estuaries and they actually can't shut the shells, and so it's problematic. We have this a little bit here. It's only really a problem when the salinity is higher than 15 parts per thousand. So again, high salinity is a problem, but the damage does reduce the market value. This is something that hits the adults. It's dermo. Dermo is chronic in the bay, and it was actually the Gulf of Mexico that infected the Chesapeake Bay back in the 40s with this little parasite, so not bad. But anyway, the healthy oysters are nice and fat, and this is one that's infected with dermo. And dermo is a single-celled haplosporidium, and what it does, again, is basically eats the oyster. It consumes its energy, it proliferates in the cells, and it reduces its condition. So high infestations can devastate populations, but again, most of the time you will find dermo in most of the populations along the east coast of Gulf of Mexico. So generally the cycle of dermo is that it pops up in the spring, and then summer you start seeing infections, but the heavy infections and high mortalities occur in sort of late summer and fall, and that's when you get your death, especially in the older animals. And then in winter, the temperature knocks it back down again. It basically goes to sleep for the winter and then pops up again in the spring. So it overwinters in the animals. So they are a sort of a source of reinfection or elevated infection. And the most important factors for dermo are temperature and salinity. So they like high temperatures. You see, these high temperatures are not particularly high. 65 Fahrenheit isn't particularly high. And that 15 parts per thousand isn't particularly high either. So in the Gulf of Mexico, we have a long time period where we have these kinds of conditions where dermo can proliferate. And it gets knocked back when the temperatures drop to about 15, so our winter temperatures, and when the salinity drops down. So again, it's the same sort of message where you have high salinity and high temperature, you have problems. And this parasite becomes a real problem with the adult oysters in the Chesapeake because it accumulates, and over time it accumulates in an individual and just gets worse and worse. And in the Chesapeake, they actually reduced the harvest size so that they could harvest these oysters before they died of dermo. Fortunately, it doesn't hurt people, but I personally don't like the thought of eating infected oysters. It's so heavily infected with this thing that we have to harvest them. So what are going to cause these changes? Well, obviously there's management issues, water withdrawal and so forth, but climate is a huge overriding umbrella on top of everything. And so again, if you get a lot of rainfall, it's less important that urban and agricultural withdrawal is taking the water because there's enough for everybody. So what's going to happen in the future? Well, again, this is just prediction and modeling, and nobody really knows. But we're expecting the temperature to increase, and we're starting to see a little bit of that. If you go back to remember the ANO data that I showed you, you get that very slight increase in temperature. But oysters are on the southern edge of their range, and so again, if you're nice and comfy in the middle of your range, you're doing fine, you can take a couple of degrees increase. If you're on the hairy edge of where you can thrive, and the temperature goes up by a couple of degrees, especially if you get temperature spikes and fluctuations around that, that could put you in trouble. Rainfall changes, again, we talked a lot about salinity, it's very important. We're expecting increased storm events, which is great, brings rain, but it also brings periods of very low salinity, which can cause high mortalities in oysters. They can tolerate the high salinities. It's not the oysters really that can't tolerate the high salinities, it's the fact that they have all these other things coming in when there's high salinity, the predators and parasites. The oysters themselves are okay in the high salinity, but it does cause these other problems. And then changes in nutrient dynamics, which is not something that, there has been some work done on it, but if you change the floodplain, and you get less flooding at the floodplain, you might get fewer nutrients coming into the bay. You might get a starvation situation, that's an extra stressor, and on top of everything else, food may go to the oysters. Changes in carbonate chemistry. Oysters and other animals have shells made out of calcium carbonate. When carbon dioxide dissolves in water, it reduces the pH. It's a complicated sort of carbonate chemistry system, but it creates a more acidic environment. It's harder for the oysters to make their shells when it's acidic. And so this is not recognized really as a problem here. It hasn't really been looked at in the Gulf of Mexico, or at least not out there. But in the Pacific Northwest, the aquaculture growers, the hatcheries they nearly bankrupted them when this very low pH water came in, it was upwelled in, and they lost their entire crop. So it's not a problem here at the moment, but it's something that we need to understand in case it changes in the future. So what can we do about all this gloom and doom? Well, I like to use the analogy of somebody that's chronically sick, getting the flu. We all know about this with COVID-19 at the moment. If you have a chronically sick ecosystem and you hammer it with another stressor, you could tip it over the edge. It's about tipping things. And so what we can do is try and control some of those local stresses in the hopes that we build a healthy ecosystem that can be more resilient to some of these global stresses, things we can't do anything about, like climate changes or anything, like oil spills. We can't do anything about it. Humans can, but we cannot. And so what we as a community can do is manage well locally to increase the health of the ecosystems so that they can survive into the future. Questions?
Any questions? That was excellent.
Okay.
Thank you.
Everybody's stunned or asleep or something.
Yes, Chad?
Music lights, I suppose.
Yeah.
You wanna move it closer to your.
Pull it down towards you as well.
Okay, thank you, Sandra. Can you all hear me? I don't know if it's.
It's only picking it up, it's not amplifying it.
Gotcha.
So what, as you said, what we're doing is recording this, and then people will be able to watch and or at least listen to it.
Just going back to your fish association graphs that show trends in population over time. In the bays, was that in the bays in general, or was that by habitat? So was that drawing it from the oyster habitat, or is it just in those bays specifically?
It's bays, it's the area, it was basically all the film data. I mean, correct me if I'm wrong, Ed, but I think it was just basically extracted from. Go ahead.
That's correct. It's, they're trends, but they are standardized by the zones. What that means is, we think this is descriptive of the trends that they will draw. That would be probably the better way to answer the question of whether the overall population has changed. If we're only looking at what's associated with oysters, then it's really easy to imagine that these mobile organisms have just moved elsewhere and they're next in this curve right now. We can investigate that question.
Yeah, I guess, would it be, how meaningful would it be to look at species such as blue crabs, snow crabs that are more closely associated, less mobile, with oysters, and just kind of gauge their kind of couple of habitat and the species profiles, so black drum might be another species. I was just wondering if that'd be a meaningful exercise for understanding what's going on today.
I looked at a number of the species, not blackbird specifically. Some of them are difficult because the gear that the FWR group does use is not really great at getting into nooks and crevices with lost snow crabs. It's a fantastic sampling program, which is great for having access to the data, but it doesn't trap all animals well. Some of the issues with mullets are that they can jump over nets, and so one of the things you see going on with that is there's only a small size possible mullet that are actually well captured by that gear, so you do have those issues. I've looked at blue crab and they're so-so, meaning that the confidence intervals are pretty wide, so the graphs are a little bit less impressive. You see the trend line going through, you think you know what's going on, but if you look at the confidence intervals, then it's a lot harder to see the pattern of the blue crab. But if there's interest in fish infestations other than oysters, we can take a look at that, and we can look specifically at what's going on in the bay overall, or specific regions in the bay. I think there should be a lot more caution put on in trying to figure out what's going on because of the oyster decline from looking at the specific habitats, and that's because this data set, these data were collected in a standardized fashion, so they're sampling habitats specifically in a statistical program. I mean, it's not really well suited to answering this question of, well, what happened with this habitat change? So, I guess it's a question like, it's harder to sort out where did those fish go to, just from using that, but we can try.
Anybody else?
I've asked a couple of comments on the Madeline. I doubt the people that are gonna watch this on the website heard that answer. I think that's an important answer. If you're like watching this on our website, I've had some people ask about public input and stuff like that. And so I'm just envisioning me sitting here watching this. That's a great answer. But I don't think
We should have a lot of.
anybody, yeah, I think that's my
Yeah.
point. That's all I'm saying.
It's just.
All right, well, we'll try to, we're trying to improve this audio. We're gonna take the mic back next time. Okay,
It's
yes,
still a work in progress, Chad.
Yeah, I understand.
Yeah,
I get that, but I think that's what
It's good
some
input.
folks are looking, they're looking out from the fishbowl here, we're
Yeah.
in here, they're out there.
no, point
Anita?
taken.
If that's, can you hear me?
so that's not an amplification mic, it's only a picking up
Oh, right,
audio.
okay. So I think one of the, that's a very good point, as we try to get the public to be a part of this and bring them all along. I noticed one thing on your slide, you spoke specifically of Atlanta and water withdrawals, and maybe in the future we should consider that whole basin above us. And because the agricultural withdrawals are, significant, very significant. And I think that in the future we should deal with that entire, watershed.
I did, point taken, I did mention agricultural withdrawals, but I did point out Atlanta specifically, so.
Yeah, and I think that's probably gonna help us.
All right. Okay, thank you so much. So let's go ahead and go on to our next presentation. Portia from FDAX will give us our aquaculture industry regulatory framework overview. Yeah, I guess it's a question like to be
So at the last meeting, there was a request to hear a little bit about our leasing program and then also some of the projects that we're working on in Apalachicola Bay with respect to aquaculture leasing. So just to give you guys a little bit of overview of what aquaculture means in Florida, we probably have the most diversity of all the states. So we produced over 800 species here in Florida. And in 2018, sales were around $72 million, and we've got 1,000 certificate holders. That's their license that they hold to grow and sell aquaculture products. You can see the majority of those are ornamentals, so those are tropical fish. There's a ton of tropical fish production in Tampa area, and also in Miami. And then shellfish is 17%, so there is a lot of shellfish production in Florida as well. Food fish, alligators, aquatic plants. There's also corals, live rock, I'm gonna forget a lot of stuff, shrimp, you can name a ton of different products. So just to give you guys an overview of what aquaculture actually entails in Florida. And then I know Felicia went over this a little bit with her presentation, so I'm not gonna spend a lot of time on it. But the programs that we have within the Division of Aquaculture include the Certificate in Best Management Practices program. So that is the land-based farms. We go and inspect those to make sure that they're complying with best management practices. The leaseholders also have BMPs that they have to follow specific to aquaculture leasing and shellfish production. And then we have our shellfish harvesting area classification program. So those guys go out and do water sampling to make sure that the shellfish that are harvested, whether they're wild or aquaculture, are safe for public consumption. We have our submerged land leasing program, which I'm going to talk a little bit more about. And then we also have the shellfish processing facility certifications. We have inspectors that go into the shellfish processing sites here in Apalachicola and throughout the state. I think there's about 100 of them. And they make sure that they're following sanitary practices. And then FWC's role with respect to shellfish, I know Felicia covered this too. But the first one, setting the season size and bag limit, that is specific to wild products. So there is no season, bag limit, or size limit on aquaculture product. And that's really where the two products kind of diverge. The rest of the regulations about when you can harvest, when you can be on the water, and if those shellfish harvesting areas are open or closed, or selling to a certified dealer, all those are the same, whether it's aquaculture or wild product. So then just to give you a little information, so as of, this is at the end of January, we had close to 780 active aquaculture leases throughout the state, covering close to 3,000 acres. So 712 of those, they're broken into all different categories, so I'll kind of walk through those just to give you guys a little understanding. 712 of those are raising shellfish. We don't require that they break down between clams and oysters because conditions change. People might decide they want a polyculture. So it's a shellfish aquaculture lease, so they can raise any native shellfish that's approved. In perpetuity leases, we have about 47 of those left statewide, so those were issued prior to the 90s. Some of them were issued close to 100 some years ago, and there are a few in Apalachicola Bay. And these are a little bit different. These folks don't have to produce a certain amount. There's a lot of regulations within the aquaculture program that people that have in perpetuity leases don't have to follow, because they were issued prior to the program. There's also live rock leases. Those are primarily in the Keys. There are some in Pinellas, but they basically take mined limestone or quarry rock and put it on the bottom, and they let different organisms colonize, and then they sell it into the aquarium trade. Management agreements are for research and education, demonstration. We have some of those throughout the state. And then water column leases, we have 181. So these are the leases that allow the off-bottom culture, the suspended or floating gear. So you can safely assume those are all oyster leases. They may also be growing clams, but they're growing oysters. And in 2013, the Board of Trustees approved the first water column lease. So from 2013 till now, we went from 0 to 180 plus water column leases. So that's pretty significant growth. And then just to kind of show you where the leases are throughout the state, this is on our website. This is a new tool that we have to help people find existing aquaculture lease sites, so we don't nominate new sites if there's an existing site in their area that they can use. So all of these little titles that are pointing to a county are aquaculture use zones. So they're areas that are much larger and they're made up of multiple parcels. And then the counties that are in orange, if you click on the county title, they have individual lease sites. So not within an aquaculture use zone, just a standalone site. But this is available to the public, so they can click on any of these and see what parcels might be available within these use zones, so they can apply for those. And you can see Franklin County, we've got Alligator Harbor. It goes all the way down to Collier, and then we've also got some sites on the East Coast, so spread throughout the city. If you click on one of those areas, this is Pelican Reef in Levy County, you can see the green are the parcels that are encumbered, so those are currently under lease. And then the yellow ones are parcels that are available. So an applicant could just send in an application for one of these existing sites and goes through a very different process. We can just handle these administratively, so we can turn these parcels around in about a month. One of the other tools that we've added is an interactive map. So this again is Cedar Key, just so you can see some of the information, because they've got a lot of activity there. But the big areas are the aquaculture harvest areas, or the shellfish harvesting areas. The yellow dots are all of the water quality sampling stations. So if somebody was interested in getting a lease, let's say in the derricks, they could request the water quality data for, we have like 30 or 40 years worth of water quality data at these stations. So they can go in here and pull up the station number and then request that from our local office. You can also see the aquaculture use zones are on here. So it's just a really good tool, and this is statewide, so you can access this off our website. And then if you zoom in, this is Gulf Jackson aquaculture use zone. Again, you can see which parcels are currently encumbered, and the yellow ones would be available, so you can click on those. And it'll also tell you whether that lease is available for water column or just for the bottom. So it kind of gives you a little bit of information about it as well. This is the process if you want to nominate a new site. So if you go and look at the website and there's nothing there that you want to nominate a new site, or the department gets a lot of interest, kind of like the process with 4 Mile, this is the process that we have to go through to get that site approved. So just to kind of walk through that, the first thing we do is a title determination. We do that with DEP state lands. So we're basically asking them, is this property state owned? And are there any other encumbrances on the property that would prevent us from leasing it? And if there's not, then we move forward to a resource assessment. So Carrie and her crew goes out, they make sure there's no seagrass, there's no oysters, there's no clams. Basically, there could be nothing in the area that we're looking to lease. And they build a 50-foot buffer around the area as well. And typically when they do that, if it is within an aquatic preserve, they'll reach out to the AP staff to invite them to go along. The applicant typically goes along as well, so that if the boundaries need to be adjusted, they can do it on the water. The next step is public noticing, so we'll run an ad in the local newspaper once a week for 3 consecutive weeks to allow for public comment. And we also send it out for agency review to numerous federal and state agencies and the local county commissioners to allow them to provide comment on the proposed activity. After that, it goes to the Board of Trustees, which is made up of the governor and cabinet, for them to vote on the item, whether or not to approve the aquaculture lease. After that, if it's approved, the ball's now in the leaseholder's court, because they need to get a boundary survey, an on-the-water survey done, kind of like you have done for your home, so that we can provide that to DEP state lands, so now they can put that in their database to say this land is now encumbered by an aquaculture lease. So we don't lease something over top of it. And then the department will apply to the U.S. Coast Guard for a private aids to navigation. And this will mark on the nav charts the site so that we don't have issues with navigation. So people know it's there, they know there's going to be gear in the water column, so they can avoid that area. It's mesmerizing. So this is just a shot of the lease sites within the bay. So the red sites are those in perpetuity lease sites that I was telling you about. And some of those are very large. You can see they're just kind of spread out throughout the bay. So there is no requirement for those to be worked. The leaseholder can use them kind of as they see fit. Some lease sites that had been previously approved. There's one over off Highway 65, we've got some in Rattlesnake Cove, and then there's a block of 5 leases here. One's not showing up for some reason. And then right here is the 4 Mile Aquaculture Use Zone that was just approved in February by the Board of Trustees. We're working through the application process for that site right now. So the 4 Mile area is made up of 38 1.5 acre lease blocks. And you can see there's easements in between all of the blocks so that people can navigate between. It also helps so that leaseholders aren't right on top of each other, so their gear is not on top of each other. They've got some separation between them so they can discern what belongs to who. We just held 2 pre-application meetings last week. We had about 45 people attend, we have 38 sites. And the application window opened on Friday, March 6th, and it'll be open for 2 weeks. And these are the preferences that we worked with the local stakeholder group to put together to kind of really target some local fishermen or local oystermen to potentially pick up these lease sites. The first one is that you're a Franklin County resident. The second is that you attended one of the pre-application meetings, so you know what you're getting into. And I thought that was really a great idea for the group to come up with that, because we haven't done that in the past in a lot of areas, and I think it was really helpful to walk people through the application and kind of what the requirements are. And then also we had presentations on the economics of oyster farming, and they were very honest. You know, don't expect to be a millionaire. Like, this is farming, there's a lot of risk associated with it, and also the cost of the gear. So we shared all that information. Additionally, applicants that haven't held an aquaculture lease in the past or don't currently hold a lease have a preference. Applicants that have held a saltwater products license and applicants that have held an ABOHO. And the applicants are all gonna have to provide proof for each of those preferences if they wanna get that preference. So the lease rental fees, for an 1.5-acre parcel, a water column parcel is $86.92 a year. There's kind of the breakdown of the fees. So it's very cheap. That's an annual rental fee. And all of the aquaculture leases have a requirement to effectively cultivate the lease. So they can't just pick it up and sit on it. They actually have to work the lease. And we accomplish this by an annual audit. So every January, we send out audits to all the leaseholders requesting that they send us the information by March. So we're reviewing those now, and it's for the prior calendar year. So right now, we're looking at 2019. And what we're looking at is what they planted on their lease, and they have to provide proof of planting with receipts. And then they also have to tell us who they sold to, because we want to make sure everybody's selling through a certified dealer. And the effective cultivation threshold is 70,000 oysters per acre. So on one of these 1.5-acre blocks in Appalachia, that would be 105,000 oysters planted a year. And then just some of the really pertinent best management practices, these are the ones I get asked about the most. Only native species can be stocked. We don't allow any culture of non-natives on state property. So on state submerged lands, you can't bring in like a Pacific oyster or something like that. It has to be a native species. And it's prohibited to stock oysters from the Atlantic coast, even if it's from the Atlantic coast of Florida to the Gulf Coast of Florida. So there's a disease called MSX that they have on the Atlantic coast. We don't want it in the Gulf, we haven't found it. So we don't allow the movement of anything, even from Florida hatcheries on the Atlantic coast to the Gulf Coast. And additionally, if anything's coming in from out of state, so there are a lot of growers that are getting seed out of Alabama or Louisiana, we require an official certificate of veterinary inspection and diagnostics to go along with every shipment, and they have to send that to us beforehand. The vet typically sends it to us for pre-approval. So they can't come in and then you provide us the documents. You have to give them to us in advance to be approved. And the reason we use a vet is obviously for the Department of Ag. So we require vets to sign off on everything, but it also gives you this level of security because they have a code of ethics. So the vet is not only signing that they've looked at the diagnostics, but also that they've looked at those animals. And they don't show any signs of disease, they don't look stressed. Additionally, any oysters that are diploid oysters brought from out of the state have to have Florida genetics, Florida broodstock in their line, and they have to provide proof of that. If they are triploid, which now is, the trend, a lot of the seed that's coming in from outside of Florida is triploid, they have to use broodstock from the Gulf of Mexico. Just a few other things we get asked about a lot. The leases cannot be transferred or subleased for 5 years. So if you're the leaseholder and you apply for the lease and you get it, it's yours for 5 years. You can't turn around and sell it after a year because you didn't work it. So that's really one of the reasons we look at the effective cultivation, because we don't want people picking them up to hold on to them for a few years to sell them. So we really wanna make sure that they're working the lease. And then, they also have to have a tag or some type of identification on all of their gear. So that if the gear gets dislodged because of a storm, they can recover it. And we do get a lot of calls from people that find gear that's got an AQ number on it or something like that, and we can tell them who it belongs to, or we can contact the leaseholder to get the gear back. Because nobody wants to lose their stuff. And I think they learned this lesson during Hurricane Michael, because there was a lot of gear that was lost, and it wasn't marked, so nobody knew who it belonged to, so people lost their gear and their product because it couldn't be returned to them. And that's all I have for you guys. Does anybody have any questions?
Jim. Jim Estes, and Portia, you know that I usually hang on your every word. But I did notice, so when you were talking about the AUZ at 4 Mile, I think it's important for everybody to understand how controversial that additional aquaculture facilities in Apalachicola Bay has been for many years. And I think it's important for, my question is how did you decide where to place this?
Well, there were, many of you may remember, there were 4 areas designated way back 30 years ago as potential aquaculture use zones. So the first thing we did when we were talking about a new area was go and look at those areas again. And 2 of them had filled in with seagrass, so they were no longer suitable for aquaculture. So we kind of had 2 areas left. And really we worked with a local stakeholder group, and they helped us kind of identify areas that we would not conflict with existing users. So we kind of had an idea of where to look, but they really directed us, not only, when we came back to them with areas that were suitable from our perspective that there was no resource, their expertise was, there's shrimping activity here, we need to avoid this, or we need to drop this row of leases. Just kind of work through that. There is an in perpetuity lease off to the west of this, so we built in a buffer there as well to make sure that we weren't infringing upon that lease. But yeah, really just trying to find areas that we weren't going to conflict and building off of local knowledge.
Great. Chad?
Thank you, Portia. Are most people using diploids for aquaculture, or diploids in the bay and or the region? And is this site intended, is there a preference from the state of whether to use diploids, which are the section you went to, and if so, is this site, if this site was predominantly farming diploids, was this the location where some of that larvae could be captured for productive wild harvest or wild reefs in that general area, or is that where would happen to the spat and the larvae from that area if they're diploids?
So we let the grower determine what they want to grow, as long as they're following the BMPs for health and genetics. They can grow diploid seed or triploid seed, it's up to them, it's their option. And I've heard pros and cons of each. The triploid is a little bit more expensive, sometimes it's harder to get. But the issue with the diploid seed is they are spawning, so you've got a lot more work to do, to clean off your oysters for sale. But we don't tell them what they have to grow. As long as they follow the BMPs, they can grow what they prefer.
If I can just follow. Sure. So, was there any consideration for it at all? If this was an area that's being farmed with diploids, is it in consideration of capturing some of that, expelled spawn larvae and going to wild reefs? Is there connectivity issues or, either concerns or benefits? I guess we'll turn it over to Sandra.
Go ahead.
Just grab one of these pointy things.
Yeah.
Great system. Sorry, people. So the thing about oysters is that they're broadcast spawners, so just because the aquaculture lease spawns doesn't mean that that's where the larvae are going to end up. But in terms of contributing, sure, if you've got something that's reproducing, it'll swish around in the bay, just the same as any other oyster larva would. In terms of using that wild strike for other purposes, I've actually been talking to a number of the aquaculture guys who, if they get mortality on their leases, and they've got wild strike on it, I can actually take it and we can use it for restoration within that bay. So I'm working with them FWC on special activity licenses for the agriculture guys, because that dead shell is of no use to them, but it's got wild animals on it. So that's just one avenue that I think they could be contributing to some of the replenishment for that.
Great, George?
My question is on timeline, it sounds like the application process has started. When would, assuming all goes well, when do we anticipate these sites will develop?
A lot of that's gonna depend on how many applicants we get. So when the window closes on the 20th, what we'll do is look at all those applicants and the proof of preference, and then I'll kind of break them into tiers. So people that meet all 5 preferences will be at the top, and then 4, 3, 2, 1, 0, and then give them random numbers to kind of pick who's 1 through 38 within those tiers. And then we give them 15 days to submit the application fee. Now, if all 38 submit the application fee, great, we can get started. If one of them doesn't, then I have to go to 39 and wait 15 more days. So a lot of this is dependent on the applicants at this point, and kind of how they follow the process. But once those applicants have been identified, we'll hold a public meeting where they can select their parcel. And that's kind of the reason for the random number generator. So whoever's number 1 picks first out of these blocks. And when we present it to them, we'll show them where the US Coast Guard markers are. Because you would want to pick one that doesn't have that, because it'll be your responsibility once the lease is executed. But they also kind of like to pick who their neighbor is, so they might work together, like, well, I want to be next to Tom, because I know he knows what he's doing, and we're going to work together. So they kind of like to pick where they want to be. So we allow them to select their location, then after that, it's on the leaseholders to have the boundary surveyed. So to have the area surveyed and marked. And that depends on the surveyor. That can take 2 months, it can take 6 months. We are hopeful that we will be starting this summer, that the leases will be surveyed and people can start preparing and working. And one of the things that we're working on is trying to put together a training program for them that coincides with important events throughout the year. So before they get started, we want to do some business planning with them. And this is free training. It's not just for these folks. It's for anybody that's interested in coming and learning about it. You don't have to attend, or you can attend all of them. It's kind of up to the interest of the individual and how much help they need. But then we're also thinking about talking to them about purchasing gear and the type of gear and the line layout that you might want to do on these parcels because of the dimensions. So we're really trying to give them all the tools and resources that people will need to be successful.
Thank you, George. Appreciate it. All right, our next presentation is a briefing on the Apalachicola Bay System Restoration Act by John Lucas from DEP.
Good morning, as he said, I'm John Brucker, I'm the Central Panhandle Aquatic Reserve Manager, and I am going to give a brief kind of discussion about some of the shelling and mulching efforts that have been done in Apalachicola Bay, and then briefly talk about some of the larger projects that have happened more recently. So, as Sandra put up earlier, this is a map she had where all the restoration sites have been, but I thought it was a crowded map, so I just want to show where we know or where oyster maps have, or where oyster reefs have been mapped in the past. So why do we do oyster restoration? And a lot of it is to promote reef development of oyster by restoring the degraded, depleted, or dead habitats. Mulch material is used. It's any suitable substrate that is good for the settling of oyster spats. We tend to place the suitable mulch material on existing oyster bars for the setting of the native oysters and for pollination. Placing the material creates a three-dimensional reef structure, stimulates spat, accelerates the recovery process, increases productivity, helps us to sustain fisheries, and continue to assist with ecosystem functions. The benefits, obviously, as I just mentioned, are increased fishery and wildlife habitats, filtering of water quality, improved stability, of some of the habitats. There's also the economic benefits of harvesting, processing, marketing the oysters, and then also provides jobs, employment, and income for local businesses and the public. So historically, shell additions were first recommended in Appalachia in the 1880s. Division of Agriculture planted the first known shell of about 15,000 barrels in about 1913. Shell distribution increased a lot in the 20s. It's just a personal communication with Paul Zajac for DAX. A lot of this numbers I'm not just making up, or I don't just know off the top of my head. DAX has a great summary report of all this if anybody is interested in it. It does have a lot of good information. In around 1949, there was a state mandated program requiring that oyster shell be returned to the public oyster beds. You can kind of see in this nice old photo, we're dragging a barge full of oyster shell out to some of the old beds, and the oystermen riding out to go dump it out. In the 70s, more than 4 million bushels of shell, covering approximately 400, or I'm speaking acres, I'm speaking acres, I'm speaking hectares, 1,000 acres. And so that's a lot of shell material going down. And in the past, there's been some shell buyback programs, Project Oyster, shell recycling programs that occur with local restaurants. But sometimes the funding for those projects are short-lived and they don't tend to really pan out for long periods of time. So more specifically, kind of skipping over a time period, getting into the late 90s. I've got a long list of numbers here, but you can see that between 99 and 2004, there was 45,000 cubic yards of shell that went down. In 2005 and 2007, we didn't have any mulching on Apalachicola Bay. It was only in Escambia, Santa Rosa, and Bay counties. You can see that it's all processed shell in from 2008 to 2012. Again, about 45,000 cubic yards. This time we have processed and some fossilized shell. In 2013, we didn't have any mulching activity, and in 2014, there was just a small amount of fossilized shell deposited back in the bay. The three bigger restoration efforts or mulching efforts that occurred in the bay in 2015 was the FWC's NICWIF project, where the 3,000 cubic yards was placed on 3 different reefs, and the different shell densities have been analyzed. That's Melanie Parker's project. Some more information on their project, they'd be able to provide that to you data-wise. In 2015 also, one of the projects I managed, the Apalachicola reefs for our NERDA project. There was approximately 25,000 cubic yards put on 16 debilitated reefs. And then in 2017, with a different pot of BP money, part of the Gulf Coast Ecosystem Restoration Council, 95,000 cubic yards of lime rock aggregate were put on 14 additional reefs, or on different sections of some of the same reefs as our NERDA project. Okay. So I just wanted to show some pictures of some of the efforts of the methods of getting the material out into the bay. You can see in the past, a lot of the local oystermen will pull up along the shoreline, and a large amount of mulch material, most of the time oyster shell material, will be loaded onto their boats. And in the process, this is just another photo. You can see that they just use large heavy equipment to load large amounts of shell to boats. You can see they all line up, and everybody takes their turn. They have bins, they dump into the bay. A bunch of different reefs are selected, targeted, The other method that was used more recently for a lot of the reefs that we're restoring with NERDA and the restore reefs, you can see they use the barge. You can see that sometimes they take their job very seriously in terms of jetting the material out into the bay. And so one of the major questions we have, or that we've started to ask ourselves, notice on what we're seeing out there, is what is the best method of deployment of the coastal material? When you're spraying it out like this, do you really get a good amount deposited where you want it to, or is the manual deposition better with the guys dumping it off the boat? Is it more accurate, or if they used heavy equipment to dump it off the boat? In some areas I've seen dump trucks on barges dumping shell off, but you get a more concentrated amount in an area versus large spread. So, questions that we ask ourselves all the time. Just kind of anecdotally speaking, we've seen some reefs. We're right in the middle of the reef, you'll see a large halo of where the boat was parked and sprayed the material off. And so there's material all around this circle. You can tell that's where the boat was and that's where it sprayed the material. So right in the middle of the reef, there's not material getting down where we want material to get down. Well, there's our restoration reef. You can see again, as Sandra mentioned earlier, the green dots are our restore reefs, our NERDA reefs, and our yellow dots are our restore reefs. We have monitored, collected material for our NERDA sites 3 times. We do it every 6 months. Obviously, some hurricanes have gotten in the way of some of our sampling efforts for safety-wise, access-wise. So there's been some major changes that we've noticed. And then with our restore reefs, we're just starting up our 3rd and final round. It's a much shorter project. So the NERDA project, just as I mentioned, in 2015, 25,000 cubic yards. The monitoring, you can see these are what some of our samples look like when we're pulling up the fossilized shell material. The NERDA reefs that we have in Appalachia just have the fossilized shell material. The restore reefs out here in Appalachia are using a lime rock aggregate that is a little bit bigger in size. You can see that is our quadrite we use. Typically when we're sampling, we have 5 quads on each side of the boat. We bring everything up and bring it back and sample it and measure for oysters. And we do the same process with our restore reefs. And for both projects, we're also doing side scan mapping to try to see if the oyster reefs are moving. A lot of this mulch material has been shifted around. As you know, there's a lot of currents in Apalachicola Bay, a lot of sand movement in Apalachicola Bay. So mapping the reefs to see if our restored or if our mulch material is actually staying put or if it's shifting is incredibly important in the management of the restoration efforts. Next slide. Looking ahead, or just some thoughts, as I said, our team comes across, is that mulch material should be considered an essential management strategy for restoration, especially if the current shell budget is deficient, which if there's not a lot of oysters out there replacing themselves, we need to find some sort of method. But in all fairness, it should not be the #1 reason, or it should not be the only thing expected to assist with the recovery of the oysters. If spat recruitment is low, even large amounts of mulching may not lead to recovery. So in other words, if there's not enough spat, if there's not enough input going back into the bay, there's no way it's going to recover if we keep taking from the bay. The restoration actions, including shelling, should be managed, monitored, quantified, and tracked. If we're just out there dumping material and not really keeping track of it, what it's doing over time, how can we really measure success? How can we really tell what's going on or see what's going on? And finally, examine the past and current restoration efforts to maximize potential future. In other words, look at some of the efforts we've done so far. Consider what we've done wrong. Do we need more sampling points? Do we need different sampling efforts? Do we need the same kind of rock material? Do we need different kinds of rock material? For instance, in our NERDA project, we have reefs in the St. Andrews Bay system and in the Apalachicola system. In Apalachicola, we have the lime rock aggregate like we have on our restore reefs here. In St. Andrews, we have a granite material. So there's cost that comes into play, being able to get the material that comes into play, but also finding what works best in each individual bay because there is such a variation. That is all I have. I wanted to keep it brief because I could have spouted out a whole bunch of numbers and just not like quantities of rocks. If you guys are interested in some of those, I would suggest the DAX report has lots.
Great, thanks, John. Any questions? Go ahead, Sharon.
John, is any harvesting going over in the other states, in Panama City and Pensacola?
Off the top of my head, I know that in Pensacola, they're not harvesting on the reefs that we're restoring. I've been in touch with the TNC folks over there, Nature Conservancy people. They're gonna be working on some other reefs, and I think that just because there's been so little growth over there that most local people are not looking at the reefs that we have material on. In St. Andrews, I can't be 100% sure, but I personally have never seen anybody out working any of them. In West Bay, there may be some areas, FWC might have some info on that, just because they have some restoration reefs they built out there, Katie Conchar's group. But as far as I know, I have not seen any oystermen working on any of the reefs in those areas.
Is your data collection better over those areas than over here?
We're seeing a lot more adult oysters and a lot more growth in those areas where St. Andrews, we did see some loss of the reefs. We've seen some reefs completely disappeared, but a lot of that we can blame on the shifting of material from Hurricane Michael, just the impact. But despite all that, and despite whatever water quality issues may have happened in the hurricane, we are still seeing adult oysters, and we saw an incredible amount of spat and sea oysters over there.
And when y'all do y'all collection data, y'all do the same area every time, don't you?
That's correct.
The reason I'm bringing this up is because I know the areas they collect here, and they can go and dive one day and get some good data. They go back, they won't find any. When an oysterman goes across that, he's tonguing and putting it all on his cupboard, and he moves it back when he sits down and culls it off. So their data is not accurate as it should be because the guys is constantly moving their data.
Okay. Any other questions? Thanks. Oh, sorry, Anita. Oh, sorry.
Kind of to piggyback on what Shannon's saying, can you give the committee an overall assessment of Apalachicola Bay oysters, the reefs you're monitoring and what you're seeing? Also, jump on the back kind of question.
Yeah, actually, I can put up a graph real quick if you'd like. I did bring something just as a plug. We just finished our yearly report for all of our NERDA monitoring for all 3 bays. I did send it out to most of you, I think, via email, but I can send it out to Felicia to send out to the group or whoever. But if you would plug that in, there's a PDF on there, and I'm gonna have to have you scroll through. Just before we, sir in the back, did you have a question?
Well, yeah, I mean, after, well, the question is, so 2 things. One, how many, gas track, how many acres have been restored using culture? That's one of the things.
Total acres?
Yeah.
Yes, and actually, okay, if you go back to my PowerPoint. Or actually, you know what, I do have that number real quick, I do have the old. Let's see, so, from 2013 to 17, about, just shy of 500 acres have received, mulching material. A lot of other years, let's see, from 2008 to 2012, 175 acres. In a lot of other years, it was very small, I mean, no more than 175, but a lot of other years it was 35, or it was very small amounts being put back into the bay, very few acres of being covered.
So, with that dynamic, when we're looking at oyster spectrum, for Appalachian Bay, is it now, or should it now be considered a most map area for most years?
That is not for me to make a decision on. Solely because when it comes to saying whether or not it's spat limited, you really have to look at the spat numbers. And the FWC group, they actually do collect all that spat data, so they'd actually be able to give you a full assessment. What I can tell you from my data is that we are seeing less numbers of spat, so we are seeing a decrease, but I can't, officially say if it's or determine if the bay is now limited or not. I apologize for scrolling through, but wasn't sure if I was gonna get asked about this or not. And as I said, I can send this out to everybody.
We can post, if you send it to Maddie,
Okay.
they'll post it on our website. All the presentations will also be posted to the website, so you should be able to access all of this information.
I'm sorry, oh my gosh. Okay, so as I mentioned, we have completed 3 rounds of sampling. We try to do every 6 months, but as I said, Michael kind of got in the way. You can see in the first 2 rounds of sampling, total number of live versus just total number of dead, total number of oysters we're collecting. We are seeing a drastic decrease in the number of live oysters collected. We go to the same spots, and it's a lot less live and a lot less dead. If we break it down by size class, so you can see that in our second round of sampling, this was in the fall, winter of 2017 to I think early 2018, we had a good increase in spat, but again now we've seen a very large decrease in spat between rounds. Now granted, a year passed, and so there could have been a lot of changes in the bay. We lost a lot of time sampling because of Hurricane Michael and other things. So 1 year passed between rounds 2 and 3, but only 6 months should have passed. So there could have been a whole lot of changes, some immediate, monitoring after the bay, things like that should have been done, or but unfortunately money, staffing, access, and things like that kind of affected our sampling times. Another important thing to notice is that when we first started sampling in the spring of 2017, we found 149 adults total. I'm trying to wrap this up, I know we're on a schedule, sorry. But you can see that over time in our 3 rounds, we had a decrease in adults, and that on all the reefs in this past round, we only found 2. In our restore monitoring, we've done 2 rounds of monitoring, we've only found 7. So oysters are not making it to adult size in Apalachicola Bay. Just an important thing I can show you real quick too, and then I will wrap this up, is what we're seeing in terms, I'll show a shell distribution, shell height distribution. Is that in all 3 rounds we're seeing No, it's alright.
Maybe because it's PDF.
Okay, well, you can see that spat size oysters are typically between 0 and 25 millimeters, and that in all 3 rounds, we expect to see spat, we expect to see a spat, put back by live oysters. But what we're not really seeing, in the first round, we did see some seed oysters growing and even some adults, so the material had been out there for a while, we expect things to be growing and moving. But in subsequent rounds, populations are struggling to get really beyond that 25 to 30 millimeter range. So just getting out of spat, getting into that seaside range, and then we're seeing very, very low numbers of seed size larger than that, or even adults after that. And that's kind of the big mystery now, is what's stopping them from getting past that stage in larger numbers. So I will send this out, it's a full report, it's got all 3 bay systems. If you have any questions, I will leave a step.
Can you show us table 4 real quick, explain table 4?
Table 4.
That one for the bushels per acre.
Steve came prepared. So, the bushels or the bags per acre, this is a...
There's more below that.
I'm sorry?
Also, I don't know.
Do my best. Well, what's important, or I can show you the rest in a second. This is a formula we use, based on a number, that's the DAX protocol that they use for estimating the number of oysters per acre for density estimates, but also for bags per acre for production. And what's important to notice here is that progressively the estimates for the number of harvestable acres in all from round 1 to round 3 basically goes to 0, with the exception of Norman's Bar North, because that's where we found the two adult oysters in this past sampling round. If I scroll up, this will make a little more sense. It's below it, I'm sorry, I do apologize. Is that to be a healthy reef, the estimates need to be 400 bags. I'm sorry, 200 bags or more is capable of sustaining a limited harvest. A commercial harvest needs to be 400 bags per acre. Currently, our big winner is at 4.8 bags per acre, unfortunately. Basically everything is considered depleted on the reefs that we monitor. Yes, sir.
Actually, I'm gonna have a presentation, sorry.
If you guys have more questions,
All of this is gonna come up pretty soon in our discussions.
there's some business cards you
This
guys
is
can
providing
shoot me.
excellent information for thinking through what strategies we might want to start thinking about. Okay, thank you very much, John, appreciate it. Okay, so we have one more presentation, which I'm gonna give. You want to take right now or after the presentation? All good for another 15 minutes, so? Okay, I'm gonna try to go, I've got a fair amount of slides, but I'm gonna pretty quickly. I think some of this is sort of obvious.
You're not allowed and
Where's the little device?
it's above the laptop, above this laptop right there. Sorry. Hold my hand in your face. Yes. Well, no, use your advancer.
I'm really advanced.
You got the right.
Okay, so you asked us to do a presentation on the process that we did in the Chesapeake Bay. It's called Oyster Futures. We started in 2016, we concluded in 2015, we concluded in 2018. The first year was just the principal investigators organizing the project, so the stakeholder participation part was about 2.5 years, and in the end, we did achieve a consensus. So it was a project funded by the National Science Foundation, University of Maryland was primary, and then University of Virginia, and then ourselves, Bob and I, from FSU, and our center were also co-principal investigators on the project. So the premise was to test whether a consensus solutions process, which is the process we're using here, can be useful in developing consensus on fishing regulations and restoration policies. And we used the chop tank, the little chop tank rivers in the Maryland Chesapeake Bay. And we used a facilitated process, exactly really the same process that we're using here. We used modeling to forecast potential effects of decisions. We had a really sophisticated model, which I won't get into much because I'm just focusing on the process part of this. So the idea is, can natural resources be better managed? And sustained by policies that are done cooperatively with all stakeholders as opposed to being done a little more top-up or whoever's hitting the agency looking for some result. And the answer, we believe, is yes. And so this was tested on a science-based method to test that policy. We had a group of scientists working with us, and we had the Department, the State of Maryland Department of Natural Resources at the table as a stakeholder. They're the management agency for the oyster fishery. So we had a division director at the table, just like we have Jen and Portia and DEP at the table. It was an important piece to make sure that all the affected regulatory agencies are there, including NOAA was there as well. Okay. This is a group of the stakeholders at our first meeting on February 27th. Okay. This is them at the end. Yeah, that's exactly the point. Still happy. Every single person stayed the entire time. One of the things we did, which is my recommendation, was to stack the deck with water, so that we had not only the science perspective, but the historic observational experience on the water. And we used that approach to test out everything that we did, the data sets, the assumptions, the uncertainty, all the things that went into the model, that we reached agreement with the stakeholders on everything that was used, so that when we started running the simulation results, people would trust the outcomes. So we had 6 watermen, 2 aquaculture, 1 seafood buyer, 3 environmental citizen groups, 1 rec fishing group, State of Maryland, the Oyster Recovery Partnership, and NOAA at the table. So the key points of the process is just like this: consensus-driven, facilitated. A lot of industry folks. This one has the same. We just haven't shown up. 75% agreement and science-based. So as we're about to start in our process here, we'll identify key issues. We'll identify a full range of strategies or options to evaluate. And then we'll do our acceptability rating to determine how well they play with the group. We'll revise those as we go forward. We'll identify performance measures, which we're going to be talking about today, so that when we run simulations on the options and strategies that we recommend, what does it do? Does it do what we want it to do? Does it achieve the performance measures? Does it improve the status quo conditions? Everything requires at least a 75% or higher threshold. The process is iterative because nothing is carved in stone. There is no vote until the very last meeting. All we're doing is conditionally making recommendations based on the consensus level of 75%. As we go through the process, we can change anytime we want. You say, I don't support this anymore. We'll go back to it. We'll do it. We'll rank it again. Trying to use the best science that we can all agree to that's rigorous. Building the goals to build trust and try to work together to meet the needs of all the stakeholders. We're not just looking out for one interest. This is only going to work if all the stakeholder interests are taken into consideration to find the sweet spot. And science should be presented in a sensible and understandable format, including data gaps, assumptions, and uncertainty for our modelers. All options, ratings, and comments are compiled and available through the entire process, which you'll see in our summary reports. I just mentioned about the decision. I think this really frees up people, that you're not actually voting when you do an acceptability ranking. You're basing on what you know right now, with the understanding that if you change your mind, we'll come back and re-rate it. It's not a vote. It's not final. There's no final decision until the very last meeting. In this process, we got 100% consensus on the entire package of recommendations at the end. This is an example of the 4-point scale using on one particular piece. Red line. So the current process is generally, there's a regulatory agency, the government. Stakeholders are talking to the government about what they want. And then the fishing and regulations and restoration policies are a result of that. And stakeholders are sort of down here. They're also, hitting the government from the side. It's not really, it's a bit of a top-down process. Now, let's go to the next slide. The consensus solution process is what we're doing here. So we have everybody, including all of our state and federal agencies at the table, working together and trying to reach an agreement on what the best management restoration policies and strategies should be. And then implement those. So it's fair, transparent, a good place to have honest discussions. Key ingredients: the scientific approach, collaborative spirit, and trust. So this is how we're running this process. So as stakeholders, we'll propose objectives, options, and performance measures. Whatever decision support tools we have, when we have models, we can use those to review those. We'll run simulations. We'll use it with whatever decision support tools we have. Next. And then we'll come back to the group with the results. You as a stakeholder will review those and determine whether you should make changes and revisions based on the results. We didn't accomplish what we thought it would. Or in combination, if it creates a problem, we need to rethink it. Anything that has at least a 75% stays on the table. Everything else is still there archived, but it's not part of the conditional package. So we had one consensus vote at the end, and that's our final report. So interesting, we had a social science group from the University of Virginia Marine Institute who did a social science project throughout this 2-year process or so. And it has to do with increasing communication. So it does this type of process, bring stakeholders together and improve communication relationships over time. Now this map shows that these are the connections that existed on workshop 1, and workshop 9 you can see the massively enhanced communication between all the different stakeholders. So this went on to, this impacts people because now agencies and different stakeholders have a better way to talk to each other, different people. I mean, one of the things when we first started the project, the water main, paid the Chesapeake Bay Foundation. So there was a long history of animosity, and this is the first time they were ever able to sit across from each other, not know each other, but sit both online. And they come to some agreement, and in the end, they actually were able to communicate back and forth. We had CCA at the table as well. So briefly on the modeling, it's a natural system model of oysters, stakeholder meetings, and the social science study, which I just described. Okay, so stakeholders decide on options and outcomes to be modeled. So you propose an option, the computer model will run the simulations. These are some examples: changing or rotating fishing areas, planting shells, fouling shell reef balls, restoring reefs. Go ahead, next. I mentioned this earlier, but I think this is an important point, is the fact that our scientists and our modelers were very open to listening to the stakeholders about the data sets they were using, about the assumptions, about everything that was going into it, and talking through it. And if the scientists didn't agree, then we'd go back and forth until there was some point where people said, yeah, I think that actually mirrors what we see in the world. But the scientists would say, yeah, first, they have to agree with it too. So it's a consensus process of reaching agreement on what's being modeled out here. We have economics, oyster biology, oyster habitat, water quality, and some of the outcomes of oyster abundance, habitat, harvest revenue, and pollution reduction. Okay. So some options could be modeled, and when we go through this, we'll have to identify those that could come down. But in the end, we have recommendations that were modeled, recommendations that were more generic, such as education, training, all those other types of things that you might expect. This is an example of some of the things that were evaluated by the work: rotational harvest, enforcement, assessment of population, limited entry, habitat modification, fees and taxes, spatial configuration, cure type stocking, marketing and business practices. A lot of different things we explored over that time period. These are things that, this is just an example of some of the results of the simulations. So over 100 options were evaluated, and performance improved over time is what was demonstrated. Go ahead to the next slide. So these are interesting statistics. So basically what the group agreed to, including Warren, who are happy with Warren, and Warren, maybe we're living today, oyster and blue crab, is the best options are going to take some time. 10, 20 years to get real. But what happens over that time period is there's major increases in abundance, 44% increase, and harvest, 120% increase. So there's a lot of statistics here, but I don't want to go into it all. Go ahead. So management options had a stronger effect on harvest than on oyster populations. They're using management in terms of regulatory, commercial harvesting, not quality. And that win-win options exist with high abundance and high harvest. For most options, the strong benefits did not start to be realized until around 10 years, as I just described. So these all represent enforcement, rotational harvest, habitat modification, planning, combined options. So this is over time that this work. It took a lot to get here because people have real fixed ideas about what's going to work. When we start running simulation, combining things, they start to say, yeah, that doesn't actually work. This is what I thought, but it's not what it is. Let's go with what the science is telling us. And this is, how we got there. So all the two scenarios of the ones that were selected show increased revenue to the water. You can see revenue is based on cost. So, and the modelers, the economic modelers, worked with the water to get all the real costs, because the costs that they were using, they said these aren't accurate. So the waterman went through and said how much it costs to drive, to do this, to that. They incorporated that data. Then they said, yeah, that looks real, and that's when we were able to get that model calibrated to the expectations of what people are seeing. Good.
Next slide.
Huh?
You're on the next slide.
Okay, oh, sorry. All but two scenarios, so this is interesting. Better harvest, better ecosystem services. All but two scenarios will result in higher value of nitrogen removal compared to the cost. So even the economics were considering the value of nitrogen removal. Okay. So what options did they choose? Next. They chose options that increased oyster abundance and harvest, that increased revenue to fishermen, were cost effective, and that increased nitrogen reduction, but were also cost effective. So again, I think this is summarized and take home points. Win-win options do exist. Most strong benefits weren't realized for 10 years. Combining options led to best overall performance, and we really found that to be the case. And after 20 years, harvest revenue could be twice that of annual public investment. So think about that. If you can go to the commission and say, in 20 years, what we're investing in there, we're going to double that in return. And after 20 years, it would be more than an 8-fold return on public investment for pollution reduction. And the last one is the choices of options have a stronger control on harvest than on the oysters themselves. Next slide, please. One of the recommendations is they wanted to use this process for all decision making in the Maryland fishery. I'm going to go back to that in a second. So this is some example. This report's available online. Some of the recommendations were enhanced enforcement, limited entry program, hand hogging. We don't have the same deer issues here as they do in Maryland. Plant more shad and spat, complete plant restoration efforts, place properly funded reef balls funded by CCA. By the way, combine the above options, use this process in Maryland. You need more shad. So how influential were these recommendations? Well, last year, the Maryland legislature passed a law. It was vetoed by the governor, and they overrode the veto on the first day of session this year. It's now law. The Department of Natural Resources shall convene the stakeholder work group to develop a package of consensus recommendations for enhancing the fishing management plan for oysters. This is for the entire state of Maryland, using the consensus solution process based on a 75% agreement level. So I would say it was very influential. The right people at the table using this process that we're describing. These are some quotes that came from stakeholders. The consensus solution process promotes collaboration, creative problem solving, sharing knowledge. This is the best process we've ever experienced. That is from 5th generation water. Conclusions. Consensus is possible. Process is important. This process really works well to work with broad stakeholders to reach agreement. And there is a solution. Scientific and local knowledge can be integrated, which is why we're all here together. Next. Looking for win-win solutions that work across stakeholder interests. Okay, that's the deal. Anybody have any questions?
Steve, your example here was in Chesapeake, and as I understand, the oysters in Apalachicola Bay in particular grow maybe up to 3 times faster than they do in Chesapeake. So could that, unless I'm wrong, could that increase or quicken the, this was a 20-year thing, so if they grow 3 times faster, it could be 3 times quicker?
That's a good question, and I would defer to our scientists on that. I think our data will have to tell us that, but we won't respond.
There's a difference between oyster growth and reef growth, which influences how well oyster populations behave. So the short answer is, I don't know the answer to that question. Theoretically, it should, but I don't think it's a straight linear relationship.
Go ahead, Felicia.
Well, I was just gonna ask Ed to respond to that, if that's okay. Ed's one of our
I
scientists.
Sure, yeah. And just once again, you were here last time, maybe introduce yourself. That's part of our science team, so.
Sure. Sorry, my name's Ed Camp. I'm the University of Florida professor pursue on this project to do some of the oyster modeling work. Just to provide a little bit more information on that. The growth rates of oysters can be highly variable, but typically we also expect the natural mortality rates to vary with growth rates. So animals that grow faster also die faster. So it wouldn't be fair to expect that oysters growing much faster here should necessarily rebuild a reef much faster than happens in Maryland. We would also expect their natural mortality rates to be faster. And then back to Son's point, which is your issue is I think how fast the population responds. And that will be influenced by the growth rate of the individual oysters, but it won't be quite the same.
Anita?
I was just curious, the reason the governor vetoed, was that political on the part of other stakeholders that weren't a part of the process? Or, I mean, quick answer, it doesn't have to be.
Quick answer was that it's entirely political. Democratic House and Senate, Republican.
Okay.
Sorry.
No, I'm always thinking of ideas we can bring the rest of the population along with us as we're, 30 people learning this process. How do we get back out into the community and communicate all we're learning so that they're buying into the process that we're all going through? Because when we get to the end and we build a report, that's, unless people in the community accept it, we wasted our time.
Which is why we tried to get everybody from all the levels here at the table who have been vetting this through the process and what they did there. Part of it is because we did it in one area probably, and there was a whole state. So some of that didn't cross, but I think by the time the next session came around, that was pretty much taken care of.
Well, to that point, one of the reasons that we decided to take the meetings and at the very least have a recording. We hope it will be video. We're not sure that we'll be able to have video, but at the very least we'll have a voice stuff on there. So,
And we do intend to, once we get at least preliminary recommendations, we're gonna have multiple steps of public, engagement. Where here's our initial thoughts, what we think. We're to take that information, compile it, come back to the group, let the group digest it, and make decisions. That's part of the process. We just haven't got there yet, because we're still working on it.
I think one more thing is I had this come up at a talk that I gave recently where people were, or a person was complaining because they didn't feel like their group or their area was part of the process. And I told them, I said, everything's on the web. So one of the things that you can point to people is that everything we've done is on the website. So all they have to do is look at it. I know it's not the same thing as being engaged in a particular meeting, but it's the best we got right now until we start doing the public workshops.
So the state of Maryland passed or adopted a fishery management plan, oyster management plan in 2019. I was just kind of curious, like how influential or what is that reflective of the consensus report from this stakeholder group in this process, and how closely married are those two, and what was the engagement of the group, the consensus group, into that management plan process? Was there lack of engagement, or can you speak to any of that?
So Maryland did the first ever stock assessment, which was done by Mike Wilbur, who was one of our main investigators on this project. He worked on other projects as well, which was done in doing the traditional stock assessment process. So the results of that stock assessment are what would be used, the science that would be used by a much larger stakeholder group. They have an oyster commission, so this is basically replacing the oyster commission with a new group that has broader stakeholder representation, and using this specific process, that's how they're going to go through the stock assessment and come up with management restoration recommendations for the entire oyster fisheries in the state of Maryland. So they're very involved, and some of the same people will be at the table there. The legislation pretty much prescribed each group in statute who would be there at the table. But it did keep the 60% industry requirement, it did keep the 75% voting threshold, it did keep this process as the way that the process would be done.
So, Chad, I think one answer to that question question was the group in the chalk tank, which is not the group that's being formed for the entire Maryland Bay. Its recommendations were delivered to DNR, to the secretary, presented, and then to the Oyster Commission. And they've begun about a year ago to implement as many of them. I'm not sure, Jeff, we know exactly what the state, but it was not a big pushback from the secretary, partly because the fishery head was on the group and helped present to the secretary. So they're implementing that plan for the chalk tank as we speak, but the broader effort for the stock assessment is using the same process, but it covers a much broader area of the entire Maryland coastline bay.
Chad?
So I've been trying to answer that question, like Felicia said, go to the website. But I'm not sure that's enough, and so I find myself trying to say something else depending on who you're talking to, because there's a wide range of who's asking the question, how much they want to know and all that. So I've been saying, also we're trying to figure out what happened, and then, why, and then we're gonna develop this management plan, restoration and management plan. I wonder if we don't need some kind of, I hate to use the term because we worked on it in this group last week, elevator speech, paragraph, something like that, where all of us are at least have some base of something we can say in a minute or two, other than go to the website, because I find that might